What if I told you that Lewis Hamilton's worst qualifying in more than 360 attempts was not just a bad night in the rain, but the beginning of a discovery inside the Ferrari SF25 that left Fred Vasseur genuinely alarmed about the car's condition? You saw Hamilton finish in the 20th position, but you did not see the hidden detail that changed everything. In the middle of the spray, during a preparation lap, he ran directly over a track cone that may have lodged itself beneath the floor and compromised the aerodynamic channels the SF25 relies on for stability. And when Vasseur ordered a full inspection after qualifying, the team found marks under the car consistent with a cone impact, exactly the kind of disturbance that can collapse ground effect downforce and destroy tire temperature on a night where the track already felt like driving on ice. Stay right here, because once you understand what Vasseur believes happened, how the cone strike, the tire temperature failure and the radio confusion combined, and why this explains Hamilton's shocking fall to last place, you will never look at the Las Vegas qualifying disaster the same way again. The Las Vegas qualifying session unfolded under a sheet of cold rain that turned the circuit into one of the most treacherous environments of the entire season. Water flowed through the braking zones, the surface temperature fell rapidly and the spray created a narrow tunnel of visibility that forced every driver to trust instinct over reference points. Lewis Hamilton entered the session ready for a challenge, but the Ferrari SF25 offered no stability from the opening lap. The tires failed to hold heat, the front refused to anchor itself on turn-in and Hamilton sensed immediately that the car was not responding to the conditions the way he expected from a machine of this caliber. As the rain intensified, the SF25 exposed its deepest vulnerabilities. The tires lost temperature before Hamilton even reached the middle of each lap, and the aerodynamic platform beneath him never settled into a predictable rhythm. Engineers saw real-time telemetry that showed abrupt changes in load and ride height, a sign that the wet surface was stripping away the precision the SF25 required to function. Hamilton described the balance as unpredictable, with the rear stepping out and the front sliding across standing water in ways that prevented him from building any meaningful momentum. It was a session where every correction added more instability. Then came the moment that would redefine the night. In the reduced visibility created by the spray, Hamilton unknowingly ran over a displaced track cone during his preparation lap. The impact looked small from the outside, but for a ground effect car the underside is the most sensitive aerodynamic zone. Even minor contact can alter airflow, distort pressure channels and collapse the downforce that keeps the car stable. Hamilton continued the lap unaware of the incident, but the car's behavior worsened immediately afterward. This moment later became the center of the investigation led by Fred Vasseur, who understood that such an impact could destroy performance without triggering a mechanical failure. Hamilton pushed onward, but the SF25 responded with increasingly inconsistent behavior. In corners where he expected a stable aerodynamic load, the car floated. When he applied throttle on exit, the rear stepped out earlier than expected, forcing him to make corrections that further cooled the tires. Telemetry confirmed the problem. The car was no longer generating consistent downforce beneath the floor. Combined with the cold track, this meant the tires never entered their proper operating window. The result was a vicious cycle where the loss of airflow stability intensified the loss of tire temperature, leaving Hamilton with no grip to fight for a competitive lap. By the time Hamilton attempted his final flying lap, the situation had deteriorated beyond recovery. The SF25 washed wide into corners, hesitated during rotation and refused to deliver traction when he asked for power. Every sector showed a deeper deficit, and the combination of cold tires, poor visibility, and a potentially compromised floor left him fighting a car that simply could not respond. When he crossed the line and saw himself in the 20th position, it marked the worst qualifying result of his career by pure pace. The emotion in the garage shifted from shock to confusion, because the performance gap was far too extreme to be explained by weather alone. When Hamilton returned to the pits, Vasseur ordered an immediate inspection of the underside of the SF25. The team knew something fundamental was wrong, and the cone strike became the leading suspect. Once the mechanics examined the floor, they found signs of contact consistent with an object being dragged or pressed beneath the car. For a ground effect machine, such disruption can destroy airflow stability and amplify every weakness caused by wet conditions. This discovery reframed the entire night. Hamilton had not simply struggled in the rain. He had been driving a compromised car on a surface where even small aerodynamic disturbances could erase any chance of performance. The core problem that unfolded for Hamilton in Las Vegas qualifying began with a car that simply refused to interact with the circuit. From the moment he rolled out of the pit lane, the Ferrari SF25 felt disconnected from the surface, unable to extract tire temperature or build the stable aerodynamic platform required for wet conditions. The rain saturated every braking zone and filled the apexes with standing water, turning each lap into an unpredictable experience. Hamilton's feedback made it clear that the tires were losing heat at a rate the engineers could not counter, and this collapse in thermal energy sabotaged every attempt he made to establish rhythm on the rapidly cooling surface. As Hamilton continued circulating, the imbalance grew worse. The SF-25 understeered through turn entry, then snapped suddenly at throttle application, a combination that indicated the tires were operating below the required temperature threshold. Telemetry confirmed that the front axle was never achieving the load necessary for reliable grip, while the rear stepped out earlier with each passing lap. For a driver known for extracting exceptional performance in wet conditions, the lack of response from the car became a sign that something deeper was wrong. The car was not merely cold. It was unstable in a way that defied the typical behavior of a Ferrari in the rain. This instability left Hamilton unable to build confidence in any part of the lap. Normally, a driver can manage wet conditions by relying on predictable sections of the circuit, but Las Vegas offered none. Each time Hamilton tried to commit to a corner, the SF-25 shifted balance unpredictably, as if the car were losing aerodynamic support at random intervals. His radio updates reflected this uncertainty. He described the car as sliding without warning, lacking initial bite, and struggling for traction on exit. The engineers could only watch the data and see tire temperatures falling rather than rising, a clear indication that the session was slipping beyond recovery. The biggest problem emerged during a preparation lap when Hamilton ran over a displaced cone hidden by the spray. The impact was momentary, but for a ground effect car the underside of the floor is the most sensitive region. Even a minor contact can alter airflow distribution, disrupt pressure zones and collapse the downforce that keeps the car attached to the surface. Hamilton did not realize what had happened in real time, and he continued driving with a floor that may have been compromised. This introduced a variable that Ferrari did not immediately detect, but it later became the centerpiece of Vasseur's internal review of the session. Once the cone strike entered the equation, the SF-25 behaved in ways that were inconsistent with pure weather-related instability. The car floated at high speed, lost suction during mid-corner phases and reacted to throttle inputs with unpredictable oversteer. Telemetry showed fluctuations in downforce that did not match the rainfall intensity, suggesting an aerodynamic disturbance beneath the car. With tires already struggling to generate heat, the additional loss of aerodynamic load created a perfect storm that made the car nearly undrivable. Hamilton was fighting physics on a night when even a perfectly functioning car would have struggled. By the time Hamilton crossed the line and saw himself placed in the 20th position, the problem had grown larger than anything Ferrari had anticipated. This was not a case of poor execution or strategic miscalculation. It was a combination of extreme weather, thermal collapse, and a hidden impact that may have dismantled the aerodynamic foundation of the SF-25. Hamilton knew immediately that the session had been shaped by forces beyond his control. And Ferrari, now aware of a potential floor disturbance, realized they needed to dig deeper to understand how a driver of his caliber could be pushed so far down the grid by circumstances that were neither visible nor predictable in real time. Ferrari's engineering team entered the post-qualifying investigation convinced that Hamilton's performance could not be explained by weather alone. The SF-25 is sensitive, but it is not a car that collapses to the bottom of the timesheets without a deeper cause. The first clue appeared in the tire temperature data. The tires never rose into their operating window, and instead cooled progressively with each sector. This behavior was extreme even for wet conditions, suggesting that the aerodynamic platform beneath the car was not generating the downforce required to stabilize load and maintain thermal energy. The numbers signaled a structural or airflow-related disturbance rather than a simple lack of grip. When Vasseur ordered a complete inspection of the car, the engineering team focused on the underside of the floor. Ground effect cars rely on clean airflow passing beneath the chassis to generate suction, and any disruption in that region can lead to dramatic performance loss. Once the mechanics lifted the SF-25, they immediately found marks consistent with an object striking the lower structure. The team connected this to the moment Hamilton ran over a displaced cone in the spray. Although the impact had looked insignificant on camera, the evidence beneath the car indicated that it had affected one of the most sensitive aerodynamic areas. With this discovery, the engineers cross-referenced the physical signs of contact with the telemetry recorded after the incident. The correlation was striking. Downforce levels fluctuated sharply in the middle of the lap, the ride height reacted inconsistently during high-speed phases and lateral stability deteriorated under acceleration. These symptoms align perfectly with airflow disruption beneath the floor. Even a minor deformation can break the pressure balance required to keep the car pressed firmly to the circuit. And in wet conditions, where mechanical grip is limited, the loss of downforce becomes catastrophic. The cone strike had created an aerodynamic leak the SF-25 could not recover from. Another critical factor was how the wet conditions amplified this weakness. In dry weather, a car might compensate for minor aerodynamic disturbances using mechanical grip and tire heat. But in rain, the tires generate far less support, and the car becomes almost entirely dependent on the underbody aerodynamic structure. The SF-25, already struggling to warm its tires, now had to cope with downforce loss at the exact moment it needed stability. Engineers saw that Hamilton's steering inputs became delayed and then exaggerated as the car moved unpredictably in slow and fast corners. Every imbalance fed into the next, creating a downward spiral that no driver could overcome.